Hi, this is Irv Shapiro with MakeWithTech. And it's clearly wintertime or almost wintertime here in the Midwest of the United States. And my lab is in the basement of our home. Heat rises, so it's getting a little chillier here. I'm going to do something a little different today. And over the next few videos, I'm fortunate to have a number of products to review over the coming weeks, and I want to get more videos out over this period of time towards the end of the year and the beginning of next year. So instead of doing detailed reviews, I'm going to divide them into two parts. I'm going to start with a first look, and today we're going to do a first look of a Sovol Sovol SV06 printer, this printer here. And then I'm going to come back a little later when I have time to do more detailed prints, and I've experimented with the slicer, I've learned the ins and outs, and do a follow-up second look. So when we look at this printer today, it looks pretty much like another generic Ender 3 clone. How many of those printers can you review, and how many should you even look at? But in fact, it's quite different. Well, to start with, it has a direct extruder. We're going to talk about direct extruders in a minute because they're really very important today, and I'll explain why. But in addition, this is not at all an Ender 3 clone. This is really a Prusa Mk3 clone. And what's remarkable about it is that, at least right now, it's on sale for $229. Normally sells for $299 right on the Solvol website. So that's 1/3 of the price of the Prusa Mk3 kit. It's about 25%, a little less, a little more depending on whether it's on sale, of the fully assembled Prusa printer. So can a printer that's that much less expensive, using the Prusa architecture, succeed? And what is the quality it produces? Now, I won't expect it to be as good as a Prusa. It's just too much less money. But overall, it's the same architecture as a Prusa Mk3. So stay tuned and let's learn something together. If you're new to the MakeWithTech videos, MakeWithTech is more than just a YouTube channel. It's a collection of resources to help people create, make, innovate at home for fun or for profit. There's the MakeWithTech.com blog and website. There's forum.makewithtech.com, a very important place you can go and share with thousands of viewers ideas, concepts, actual images, prints that you want to talk about related to these videos or making things in general. And then there's models.makewithtech.com, a new software offering that's a website from MakeWithTech that is a wonderful place to find things to print on your 3D printer because you select a model template and then you customize it for your needs. So it's more than just another place with hundreds, thousands, or even 1 million models, because these are models you customize. Now let's talk about this printer. Let's begin by just going through basically the specs of this printer. The print area, the print surface here, is very traditional to what you'd see on an Ender 3 or a Prusa printer. It's 220 by 220, so that's 220, 220 by 235. Nothing remarkable there. It is a magnetic print surface, and that's very nice, and this printer is rated to print at relatively high temperatures, so they must have done the work to ensure this is going to stick at higher temperatures. In addition, this is a PEI print bed. Those are generally more expensive and they work well, but what I'm doing right now is terrible for it. So before we go and print on this printer, we're going to want to wipe this down with alcohol to get all your fingerprints and oil off this surface. Now, the first thing you'll notice, if you've looked at 3D printers before, is there are no micro switches here. Normally there's a micro switch that helps the printer determine when it's at the top of the Z-axis. There's often a micro switch to determine when it's at the right side-by-side position. And finally, a micro switch to determine when it's in the front or the back of the Y-axis. There are no micro switches on this printer. And that's because, much like a Prusa printer, it uses the stepper motors in order to determine when it reaches an end stop. So you'll see there's little extrusions up here. I'll show you a close-up picture of that. When this mechanism hits those extrusions, you're going to hear a little grinding because it's going to try to turn the motor one more turn. There's going to be resistance. The stepper driver, that's the chip on the control board that's actually located in here. We're going to talk about that in a minute because they did something very interesting. That's located in there is going to sense that and know it's at the top. It does the same thing for side-by-side and back and forth. So that's a very advanced feature. I haven't seen it in any consumer-grade printer other than the Prusa before. The next thing you'll notice is there's no Bowden tube. On a lot of low-cost printers, you have an extruder pulling the filament off the reel, pushing it through a plastic tube, actually a Teflon lined tube to the hot end. That movement of the filament through that tube introduces a little bit of what they call in engineering play in the system. It's not quite precise. Direct extruders are very precise because the filament goes right into the hot end. There are gears in here, we'll talk about those in a moment, and they press it through the melt zone, the heated zone, out the nozzle. There's a lot less play. So for retracting, that's when you pull your filament back so it doesn't ooze out of the nozzle. Or for just controlling the flow, how fast you're pushing filament out the nozzle, direct extruders are superior. Going back a number of years, because they were relatively heavy, they didn't necessarily produce better print quality. Now, as the size has come down, the weight has come down, you're seeing direct extruders on more and more low-end printers. That's a good thing. And the extruder attaches onto this carriage with 3 bolts. It's very easy to take on and off. So if this whole thing broke, if you were in a production setting, I'd just have a bunch of these with different nozzle sizes, and I'd literally screw on and screw off the one I was using at any given time. In the second part of this review, the second look, I'm going to cover in much more detail this hot end. This is an all-metal hot end that imposes certain characteristics on how you set retraction, how you set temperatures. It also enables you to print up to 300 degrees Celsius. And at 300 degrees Celsius, or even lower temperatures than that, you can use specialized filament like nylon. Now, Sovol lists this very interestingly. They list the temperature, 250, 260 for average users and 300 C for experts. That's probably because you have to handle the filaments in a special way, and I'll talk about that in the next video. Now, other things that are unique about this printer at this price range, remember, this is a $230 printer, maybe it's a $300 printer at full price, is their dual Z axes, these Z screw rods. Now, dual screw rods often are not used in low-end printers because if they get out of alignment, it causes problems. So on printers like some of the Ender 3s, they connect them at the top with a belt. That's sort of a workaround. The approach used by this printer, where it runs them up to the top and it calibrates them independently, should be superior. Now, you'll also notice that there is a front panel here. I'll move this over a bit. And I'll take a picture of this because I think it's out of the film right now. It's a very small LCD screen, and it does use an actual knob to dial it. So you're not going to see any fancy pictures or anything on that LCD screen. Clearly a place where they cut costs. Now let me show you something that I think they did much, much better than Prusa. And it's one of two things they did better than Prusa. So if I turn this around, you'll see this is the control board. The control board's not in the base. It's not in some box on the side. It's all right in here. There's one bolt in this control board. You'll see here that I can open up this box here. I'll open it up and I'll turn around so you can see. And now you have access to the control board, to all of the connectors to the control board. On the Prusa printer, the box the control board is in is very tight and hard to get to and hard to work with. This is a wonderful, wonderful design, and I want to give credit for Sovol for doing such a good job. There is a fan also in that cabinet there. So let me tighten this back up. Now let's talk for a moment about assembly. When you get this printer, if you're used to, as I am, assembling a lot of the printers now consist of putting this gantry onto the base and you're all done. Then you connect the cables. This came with what looked like a lot of parts. I thought this was going to take a long time. My Prusa assembly, Prusa uses literally tens and 20s maybe of 3D printed little parts you have to assemble together. It took me 4 hours to assemble my Prusa printer. This printer took me 10 minutes. Because what basically happens is the base is fully assembled. The gantry, which is fully assembled with the Z-axis on it, slides onto the base, and as I mentioned, there are bolts on the side. Many printers have the bolts on the bottom that are hard to get to. These are on the side. Then you attach the extruder with 3 screws. You clip on the LCD panel. You clip on the control board case and use 2 bolts to attach the power supply. And then you connect the cables. This was a very easy printer to assemble. Now, before I do the setup of this new 3D printer, let me mention a couple things that I realize I missed. First of all, there's a pretty good user's guide with this printer. As I said, the assembly is quite simple. Second of all, I didn't mention there's an auto bed leveling sensor. Now, this is a Prusa style ABL system. Now, auto bed leveling does not mean that there are springs that move the bed up and down. It means that in software, it adjusts for imperfections in the leveling of the bed. And because this is a Prusa style printer, there is no way to adjust the bed at all. It's locked in place. All it can do is move back and forth on bearings. Those bearings, we'll see, are a bit noisy, and we'll talk about them a little later. A Prusa style ABS sensor is a sensor that uses induction. That means it can sense metal. So on this printer, you cannot use a glass bed. You can use different styles of metal beds, but you must use a metal bed. Okay, there's a power supply. On the power supply is a switch for the proper voltage. Here in the United States, I'm very lucky. If I get it wrong, the printer just doesn't turn on. If you're outside the United States and you get it wrong and it's set at 110, you could fry your power supply. So check that switch. I have it set at 110, and there's an on-off switch. I'm going to turn that on. Now, the first thing we have to do is we have to make sure these Z-axes are properly positioned, are properly aligned. So we're going to go to the front panel. We're going to click on it. We're going to go to the area that's called bed level. Click on it. And we're going to go to Auto Z Align. What you're going to see is that the gantry is going to home first, And then it's going to go back and move all the way to the top. Now, as it gets to the top, listen for the grinding noise. That's where it's trying to force it past the top so it knows where that end stop is. Now it's just going to take it back to the home position. There you go. So that has auto-adjusted the dual Z axis. That's remarkable for a printer in this price range. Now, there are two more adjustments I have to make before I make the first print. The first is I have to ensure that the printer knows the distance from the bottom of the inductive sensor to the print bed. That's called the Z offset. And the second is I have to run auto bed leveling to measure all of the points around this print bed. In this case, it uses 25 points, so it can micro adjust when it's actually printing. So I'm going to click on the control panel again. And once again, I'll show you photos of this. Go to bed leveling, go to probe Z offset, and now I can adjust that number. But if I do it now, it's going to be off a little. Why? Well, because this is all cold. And what happens when you heat up metal? Metal expands when it's heated. That's why when you heat up a bolt that's stuck, you heat it with a torch, it expands a little and you can get it off. Now, I'm going to go back and first, by just clicking on this once as if I'm all done, I'm going to go back to main and I'm going to go to prepare, preheat PLA. So I'm going to preheat this printer to the temperatures that will normally be printing at. Okay, this printer's at temperature now. So now let me adjust the Z offset. So I'm going to do two things. First, I'm going to go to bed level and I'm going to say auto home to make sure the print head, the nozzle, is at the 0 position. And it's going to use the sensor in order to do that. Now I'm going to go back to bed level and I'm going to say probe Z offset. Now when you first come into this screen, it will probably be at 0 if you've never used the printer. And you'll be able to easily move your Post-it note, I like to use Post-it notes for bed leveling, or a sheet of paper under the nozzle. But then you need to increase how negative it is. The more negative the number, the more it lowers the nozzle until you start feeling resistance. Now, I made it a little too low there. So let's see here. I backed off a little. I'm feeling resistance at 1.9. Do you hear that little bit of scraping? Not the fan hitting the piece of paper, but if you listen carefully, you'll hear there's a little grittiness when I move the paper. That grittiness indicates that the nozzle is in the right position. I'm going to click on this, then I'm going to go all the way down to the bottom and say store setting. If you do not store those settings, the next time you turn the printer on, it's going to be back at the wrong position and nothing's going to stick because your print head's going to be too high. So negative makes it closer, positive makes it farther away. Okay, we're ready to print. Okay, the filament I'm going to use today is generic Hatchbox PLA. I buy it on Amazon for inexpensively. I'm going to cut the end of the filament on an angle, as severe of an angle as I can get. And I'm going to go to the screen that says change filament. Change filament. If you say no, it just goes back to the main screen. So even though there's not filament in here already, you have to say yes. So change filament, yes. I'm going to preheat for PLA. So now it's going to preheat again, and then we will load this filament in. So it says here, waiting for filament unload. There wasn't any in there, so it didn't need to really unload anything. Insert filament and press button. Now, I'm going to show you a little trick. See how this is so curved? I like to straighten that out a little bit. I find with auto filament loaders that works better. So I'm going to push this in as far as it will go, and then I'm going to keep a little bit of pressure on it and press this here. And it should start. Yep, there it goes. It's pulling the filament in. Once it has done that, you can tell it to extrude more filament if you didn't really get it all out. Let's say you're switching colors. You want to keep saying continue until your new color is the only color you see. I don't have to purge more, so I'm going to hit continue. Now, I want to get that clump of filament out of there. I don't want to use anything metal. I will damage the nozzle. The nozzle's made of brass. This is made of steel. Bad combination. So you can either use a popsicle stick, which is what I often use, or a bunch of the printers I've reviewed recently had these little plastic, sort of worthless as paint scrapers, but because they're plastic, they're nice and soft, and I can use that to get rid of that filament that was extruded there. So I'm going to go back to print from media. I'm going to select the dog. I'm going to say print. It's heating the bed now. The nozzle was already up to temperature because we just loaded filament in. This printer overall heats up relatively quickly for a low-end printer. While talking about that, I'll mention a couple other things I noticed. The cable management on this printer is quite good, with the exception that in the back corners, there's some cables that go between the rubber wheels on the base and the frame. You have to place those carefully and use a cable tie to keep them in place. Unfortunately, the cable ties they shipped with the printer were worthless. They kept snapping. So I just used some cable ties I had around. That was the only thing I had to do after assembling it with the cables. Okay, here we go. It's going to home. Sense the bed. And now it's going to print a purge line, which comes from your slicer. And I like to sort of rub that with my finger a little bit to see if it's sticking. And it's sticking perfectly. As a matter of fact, it looks excellent. So the level looks very, very good on this printer. And now we're going to let this finish the dog, and then I'm going to print a Benji that is also on the SD card. And I'll come back and I'll wrap up this first look at the Sovol SV06. Okay, I've printed two things on this printer. The first thing I printed was this little dog. It was a little bit disappointing. So the layer lines were a little more prominent than I would expect. Now, I don't know how they sliced this, but they were a little more prominent. There was one place here where it really looked like it had trouble extruding because it wasn't uniform. There was sort of a line going around it. I'll show you a close-up. So that bothered me because I looked at this printer, I looked at the specs. It should be able to produce a pretty good print. Now, this is not a bad print, but didn't meet my expectations. So I discovered two things. The first was my belts were really pretty loose. So there are controls, there are knobs right on the front of the printer. I'll tip this up here so you can see one. There's a knob here, there's a knob on the side for tightening the belts. Makes it really easy. Those should be relatively tight. You should be able to depress them, but they should be relatively tight. So I tightened up the belt. Then, more importantly, let me actually just cut this off here so I can show you this. I looked at the reel of filament. Now, it's very easy when you're taking filament off a reel for the following to occur. For the end of the filament to go under a loop. When that occurs, your filament will work for a while and then it'll start getting tight. It's sort of a knot. And it may not completely stop the print. If your extruder is strong enough, it'll keep pulling more out, but it will cause problems. So you want to make sure all the loops are sort of independent. There's none that are crossing over. And then whenever you store it, you want to make sure you store it like this so a loop cannot form while it's being stored. So clearly I had stored this filament improperly, and that was causing potentially some of the defects. So then I printed Benji. And one of the other things, by the way, I did with this print is I turned the knob up to 200% just to see how it would go. And the result, as I said, was not great, but it might have been the loose belts and the twisted filament. So I printed a Benji. This is a really good Benji. It is not the best Benji I've printed, and I've printed lots and lots of Benjis, but it is a very, very respectable Benji. There's a little bit of defects on the top, which we can adjust with a slicer setting we'll talk about in the next video. And there are a couple layer lines that are a little more visible than I would like, but the lettering on the base is very, very clear. The lettering on the back is readable. The circles are round. This is a pretty good Benji. So overall, I would rate this as a B plus quality printer in terms of print quality. It's $230 on sale directly from the Sovol site. From that perspective, I would absolutely rate it as a best buy. So am I going to recommend this to my friends? Well, I'm still going to do some more testing, but if it continues to perform the way it has performed, I think this is an excellent, excellent first 3D printer. Well, folks, I hope you found this meaningful, you found this useful, you found it interesting. If you did, give me a thumbs up, recommend the video, share the video with all your friends, and let's continue to learn things together.